So let's start going over covalent nomenclature. Remember that covalent compounds are between a nonmetal and a nonmetal. So we are in this part of our table, right? So we are right here. The good thing about this covalent nomenclature is that the name is an actual description of the formula. So it's going to be fairly simple to do this kinds of compounds. A covalent compound by excellence, it's CO2, and everybody knows CO2, which is carbon dioxide. So in this case, it's actually telling you that it's one carbon and two oxygens, right? So it's actually telling me the actual description of it. So if we have, for example, dichloropentoxide, so the name of this is dichloropentoxide. So what do we have here? We have how much, so amount of chloro, and then we have 5 oxygens. So the last part, the I part, is still there. The I part is still there, and here we have a number, and here we have the element. Okay, so let's see some examples. Before we move on, let's remind ourselves from the Greek, not suffixes, but prefixes, because they come before. So prefixes that we're going to use for this one. Mono is 1, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octo. Just like in math, just like we name geometric figures, is how we're using the prefixes in this case. So let's give the name to some of these compounds. We have SO3. One note, mono is almost, because there's always exceptions, it's almost never used. And the exception that I have for this rule is CO, which is carbon monoxide. But other than this one, it's not very common to find a mono. So we have SO3. So SO3, the positive part, it's sulfur, and I just have 1, so I don't put anything. Trioxide, 3 oxygens, trioxide. The next one, we have 2, so it's dichloro. Remember that the first name is exactly the element. 5, which is pentoxide. Remember the determination "ide" still goes. Now for the other one, and I'm sorry I just put oxygens, the other one is 2 iodines. So it's diiodine, the name of the element, diiodine, pentoxide again, 5 oxygens, so it's pentoxide. Okay, so now we know that we are doing merely a description of the element, right? So let's do this examples that we have here. We have to change it from the formula to the name and from the name to the formula. So we only have to pay attention to the subscripts that we have in order to give them the correct name. So let me choose another color. Okay, so in this first case, we have NCl. We have nitrogen, and it's only 1, and we do not put mono. And then we have chlorine, which is 3. So I have nitrogen, the name of the element, because we have 3, chloride, and the ide because it is the last name, right? Then we have tellurium. Tellurium we only have 1. Oxygen we have 2. So we have tellurium, the element, di, the number, oxide, because it's my last name. Then we have boron, and we have only one nitrogen. So we have boron nitride directly. Remember, we usually do not put the mono part. The one, we usually do not put it. Then we have arsenic, we have 2. And sulfide, we have 3. So we have diarsenic, trisulfide. Okay, so that's from the formula to the name. From the name to the formula, it's again very easy because we have a very good description. So dinitrogen means 2 nitrogens. Pensulfide means 5 sulfurs, so 5 S's. Okay, so next one, diarsenic, so 2 arsenics, tetranitride. So we have nitrogen and we have 4. Tetra is 4. Then we have tellurium phosphide, so that goes directly 1 tellurium, 1 phosphorus. And the last one that we have, it's diiodine trichloride. So we have iodine, which is 2, and chlorine, which is 3. So that will be how you name covalent